Hey, what's up, everybody? It's your boy Algebra coming to write to you a little bit about the unit circle. Just go ahead, set your notes up, just like you see on the screen right now. We're going to talk about the unit circle. As always, this video is going to be a little bit less than 15 minutes. Afterwards, you can go ahead and start working on your worksheet, and I'm supposed to be back tomorrow. If I don't make it back to school tomorrow, then you'll have another video taking you to the next level. But for right now, get your notes set up. We're about to get started. Disregard any of the laughter or bad things heard in the background right now, because somebody's supposed to be working on her own work, but she rather just laugh and make fun of me. All right, so at this point, now that you have your circle drawn, you have the title written into your notes and everything already, the big idea and what I need you guys to make sure that you understand completely before you get started is that we're just talking about a circle that has a radius of 1. Anything else that happens from here on out, you need to understand that the radius is always going to be 1. So if I change the placement of this radius, if I say the radius is going this direction, it's still 1. If I draw a radius in facing straight down, you need to understand it's still just 1. If I put it going the opposite direction, maybe it's some weird angle that you would normally associate with the second quadrant on your coordinate plane, the radius is still 1. And so looking at this, I hope you think already, well, he just said the words coordinate plane. He keeps drawing it. He's talking about quadrants, and we've been talking about trig, that we're still going to be making triangles. But the big idea here and the goal for you guys to understand right now is that when you make this triangle, your trig ratios are always going to work the same way. So if I drew the same triangle over here, my trig ratios are going to work the same way. But what about that 1, that unit circle? The most important part is the fact that the radius being 1 is always the hypotenuse. Another vocabulary word for you besides hypotenuse would be terminal side, which means there has to be a theta involved here. Whether it's greater than 90 and you have to use a reference angle, or it's actually an acute angle to start, there's going to be a theta involved, and it's always using the x-axis. So here's my first theta. When I look at the theta for the green radius drawn in there it is. And then last week, a couple of you guys asked me certain questions about 90 degrees, 180, 270, 360 degrees, those where they were straight lines or 90-degree angles. You said always the sine or the cosine was going to be 1. You just had to figure out which one it was going to be. Going in the vertical direction, it was always going to be the sine is 1. If things were going in the horizontal direction, it would be the cosine. And that really comes from this unit circle conversation that we're starting today. So you already got that the radius has to be 1. But the real super duper important thing that you should always notice is that looking at the unit circle, the y is always going to be the opposite side. Just the way that we drew in theta, it automatically tells you that the sine is always going to be corresponding to the vertical change. Now the radius stayed the same, so now when you think about these trig ratios, it's not going to be something like 5 over 12. It's going to be something like 0.5 over 0.12. Where all of that stuff becomes either a decimal or a fraction. So that's really why your calculator comes out with all these decimals when you press the sign button. If the vertical was corresponding to the y-axis, vertical, up and down, then the x, its natural opposite, has to be going with the sideways direction. That's going to always correspond to cosine. It's your adjacent side in your triangle. So anytime that we start to set up word problems later in the chapter, if we're talking about just a unit circle in general, you need to understand that we are going to be using the y direction is opposite. your x direction is the adjacent. So in the circumstance where I take a triangle, flip it over, spin it around, and do all kinds of tricks and transformations to it, you should rearrange that so that the x is the adjacent and the y is the hypotenuse. Or excuse me, the y is the opposite. Because your terminal side should always be the hypotenuse. At this point, this is the majority of the notes part of everything. I'm going to go ahead and scroll down on the screen, pause it for a second, and get an example problem set up for you guys. But you guys, the big idea today, again, is that you take the unit circle and use it to do the same things that we talked about last week. The quizzes were pretty good. You'll get them back later on this week once everybody's taking it and once I'm back and, you know, my arm hasn't fallen off and all that good stuff. But for right now, get yourself ready. Got an example coming up. Alright, y'all, so welcome back to the video. While the video was paused on my end, Erica made fun of me for having such a loud voice and a couple other things. She said she would hate being in my class, so I'm sorry. It sucks to be you guys right now. But here's three circles. Three circles. I have pi over 3, pi over 6, pi over 4. And last week we tried to talk about this new type of measurement called a radian. Alright, so instead of talking about degrees, we could use radians. And radians always had this thing, it was pi. So where did the pi come from? It came from these circles. This unit circle idea said that pi gives you the circumference. 2 pi r was always that circumference. And so now that you see it in terms of an actual circle, you can tell that this pi over 3 is actually just cutting the circle. It cuts the top half into thirds. It's pi over 6. It does the same thing to the top half, where it cuts it into a sixth. Wow, your boy just messed up that sixth pretty bad over there. But it's alright. We're living. We out here. Much better. And so then this pi over 4, if you notice again, it's doing something very similar. It's cutting it into fourths. Why does my fourth look like a sixth and my sixth look like a fourth right now? Struggling. It's what you guys get for doing all that craziness at prom yesterday. Here we go. Got it fixed. So, starting with the conversation, you start thinking about it. How many degrees a half a circle is? Wait, that's 180. Okay, pause. I just cut it into thirds. 180 divided by 3, that's a 60-degree angle. But I put pi over 3. What I need you to understand right now, right here in this very moment where it's the most important thing on your mind, is that you have a 30, 60, 90 triangle. And you know the side ratios for that. A 30, 60, 90 triangle, for those of you who have forgotten over the past year since geometry, and I know a couple of y'all sitting in the back of the room thinking about your 30, 60, 90s because you're still in geometry, you have pi over 3 for the height and 1 for the adjacent side. But now you're looking at having a 2 here. Big idea, if the radius is 1 in a unit circle, but the hypotenuse was a 2, you already know what the sign has to be. You're just going to be dividing everything by 2 right now. So this is 1, this is 1/2, and this is going to be radical 3 over 2. That is with the unit circle. So go ahead and fill in the same information on these other 2 triangles. I'm going to give you time to do that all on your own for a second. And I'm going to pause the screen, and when it comes back in about 15 seconds afterwards, it's going to have the actual answers for you just magically appearing. Alright, so just so you know, I've got the triangles all the way drawn out for you right now. Looking at all 3 of these different types of triangles. You had 2 30, 60, 90s, and then actually that last one is a 45, 45, 90. So the important things is right now for you guys to remember that you know the exact values for these.
Why do you sound like a DJ?
What do you mean I sound like a DJ? That's because I'm algebra.
Oh, Lord.
Erica's over here making fun of me again. But she's over here sitting with her little DJ headphones on. She thinks she's so cool. I'm trying to run school right now.
Sorry.
Anyway, back to business. About 4 minutes left in this video, everybody. As you can see, the unit circle doesn't actually do anything different. We're still talking about trigonometry. So I'm still asking you to set up trig ratios. But now I'm having you associate the y value directly with the opposite side. So it's the same stuff that you did last week. But when I ask you for specifically the height of something, then you should talk about the y. You should talk about the sine every time. So a lot of you guys who will end up taking physics later on in your academic career, you're going to come into this stuff a lot. Last thing I want to do before the video runs out is give you a story problem to work on, and then you can get started on your homework. Coach Lefevre will pass it out to you as soon as this is all the way finished, and then I'll see you guys when I see you. All right, y'all, here's a story problem. This is the last thing that you're going to do on this video before you get your worksheet and you're good to go for the rest of the day, or you do not get to leave, but you have the rest of the period to work on it. So take that for whatever it's worth. If you have something else that's more important for you to study for, of course, make sure that you get done what you need to get done, but don't forget about your math homework. It will be something that you are asked to turn in. So, story says, Erica decided to go fly a kite. Her kite string has an unknown length, but she knows that the angle to the ground is 5 pi over 6 radians. Now, if Erica's kite is 15 meters off the ground, how long is the string? Now, I'm going to pause and think about that for a second, because when I think about Erica going to fly a kite, I know I'm seeing this right triangle in my head. But then I gave you a degree, or excuse me, a radian. So you have two options. First of all, you could try to go and change your calculator if you're really feeling a little adventurous. That works. But for me, what I want to do is I want to visualize this same picture, but instead of using her 5 pi over 6 radians, I want to find a reference angle that's really going to help me out. And you know, since it's over 6, we're talking about something that has a 30-degree reference angle, and it's in the second quadrant, so it's got to be a positive sign. Positive sign, thinking about it here, that means it has to be a 15 over here, 30 degrees in the bottom right corner of that triangle, and we need to find R. Now, the good thing about the unit circle, which is what we started off talking about, is that R is always 1. So now that I'm just adding an actual value into the situation, you are still visualizing everything the same exact way as before. We talk about the sign had to be the y direction, so we're going to use the sign this time. The sine of 30 degrees equals 15 over r. And that's always going to be something that works, whether it's facing the left, facing the right. If it's an upside down triangle, the y value is always going to be associated with the sine. Sine 30. We've been doing this for a couple days now. That's got to be 1/2. Cross multiply and divide, you end up with the kite string is 30 meters long. That's a really long kite string for those of you who aren't very experienced with flying kites. It must have been a very windy day to get the kite to go that far away. Whatever though, video is over. You got about 30 seconds left hearing my voice, and then you can go ahead and get started on your worksheet. If you still have to make up your quiz from last week, you need to get in touch with me so that can get taken care of. Grades have been finished, and you'll be able to get those later on this week. And again, make sure that you do your homework, even if you have something that's more pressing to get finished right now. It was your boy, Algebra, featuring Erica in the background. We'll talk to y'all later on. Peace out. Say bye. Say it louder.